Welcome. The brother asked me to make a cover for this machine, and I've decided to do a casting because it will be quicker to get all the shapes and stuff more or less in line. So all I really need to do, or things that's the really precision, would be the whole pattern. Now I'm not sure whether this cover should be closed all the way or whether there's a little slot that should be open. You can drop a comment if you know the answer to that question. The cast will cover the entire hole or the surface here, and depending on the feedback that I get back from you, I'll either mill it short or not. So I hope you enjoy this. This will be the mold that I'll be using. Now this mold, the way I made it, I've drawn up, I took rough measurements on with a vernier, a caliper, and then made a drawing up in Fusion 360, printed the outline and put the machine on top of it, having a look at where the positions are sitting and all the deviations I was able to measure, and then make adjustments on the program until I got it spot on. So I'm not sure how much of shrinkage I'm going to get. I'll do the cast and see. If it's a little bit thinner, say half a millimeter or a millimeter side to side, it's not going to bother me too much, because the end goal is just to cover up the blade, and also sitting in very deep, so it will compensate for any shrinkage. Okay, I'm going to do a bit of pressure turning here. This thing that looks so rough, it's just a rubber that's around a piece of aluminium tube. Now I'm using it, it's going to give me a lot of friction here. And the faceplate itself will also provide a lot of friction, so hopefully everything will be fine. As you can see, I've got a boring bar here, because I'm going to cut in first couple of millimeters close to the center, and then after that, while this is still in here, I'm going to clamp the part on the outside and do the remaining bits. Now the boring bar is going to give me clearance over the bolts and the clamps that I've got here. Hope it makes sense. Okay, I'm going to take my cuts at a very low RPM. It's around 160. I don't want to turn it fast, because in case this thing flies out, it doesn't do too much damage. And another thing is, I'm not sure whether this is zinc or pewter. It's definitely not aluminium, it's too heavy. Now, what I've done, I've taken letters and numbers that was cast, and I've melted them, and I've chosen all the ones that had the same color to it. Some of the stuff that I got was aluminium, and some is this mystery material. So I'm gonna cut it and see what happens. It's very abrasive resistant, so maybe if what I've said gives you clues to what it is, drop a comment. Okay, the other side cleaned up good enough to get it stuck to the faceplate of super glue, so that I can clean this face up entirely without using any pressure turning, because the pressure turning is causing a bit of a bend in the plate because it's so thin. But it's flat enough so that it will register through to the faceplate. So I'm going to clean up this side and then turn it back around when I'm done and do the other side again, just a light skim cut on the back. Now I must say this material leaves a very good finish, so I'm very happy with it. There's a little bit of shrinkage and inclusions visible here in this face here, but that's going to be on the inside of the machine, so I'm not really too concerned about that. It's not going to be visible. I don't want to take off any more on this face here because I need to I only have got 0.1 millimeters left to clean up the outside face, so I'd rather use it for that than to try and clean up the inside. Okay, I've removed the plate from the back plate with the acetone. Took around 5 minutes, and then I just knocked it out with a soft blow hammer. So as you can see, there was rings left behind. The part shifted as I was pressure turning it. The center didn't hold it good enough, so it shifted and it caused it to dig here. So that's why I've opted to go with sticking it to the face with super glue. That will keep the tire surface flat and remove any stress from the plate. So this will be my last cut on this face, and then it's just the holes that needs to be drilled afterwards. Okay, now got the plate cast and machined flat both sides, and it looks very well, very nice. Now I've had a chance yesterday to go and have a look at the machine on display, and this cover in actual fact is plastic, which to me is a bit dicey, because if this blade comes loose for any odd reason, then it's going to fly right through that plastic cover. So I'm pretty confident the metal cover will be better. Now it sits fairly well, and it's following the profile very closely, and I'm happy with the way it looks. And what I've seen is on the machines that they've got there, this cover goes up all the way up to this end here, so there's no gap. So why they didn't machine this end here right up to the shoulder, I don't know. It's a mystery. But anyway, there's 4 bolt holes. Now you got an odd shape plate, 4 bolt holes on this machine, and no perfectly square edges, nowhere. So there is one of 2 ways that you can do it, or 3 ways. You can measure it if you really want to spend 2 hours mapping out this profile and trying to get it more or less right. Or you can, if you can get a piece of paper that will stick it to the surface and punch the holes through, and if you can get that piece of paper off and it doesn't tear, you should be okay. or you can transfer punch it. So using those little niblets that you put into the what's his name, into the bolt holes. But now, say for argument's sake, you lift it up and you've got a shape that's difficult to hold into position. If you knock at this side and it moves for some reason, you're gonna land up in a world of hurt. Now I'm gonna show you a fourth method, and I think it's very easy. That requires the use of the DRO, and it's gonna save me a lot of headaches. Okay, let me show you. As you can see, I've got quite an elaborate setup here as well. Got it down on my milling pallet, 1 to 3 blocks just to get this handle off the machine here, off the table. And at the back it's been strapped to the H-clamp. And what I'm going to do is, I've got my center pin or center finding pin here in the machine. Hold on a second. Alright, I've got it close to the machine here. All you need to do is gonna bring it down with a fine feed. Just make sure around the sides that it's touching evenly, because you can see the gap. Once you're 100% sure that you've got it in position, okay, then you go to your DRO, go to your STM function, and you zero X and Y. That hole is located. So now I'm going to move to the next hole. Because this machine is not perfectly square on my milling table, using the same, get the flash on here, using the same coordinates is not going to work for the Y here. To back it out a little bit here. It's difficult to work with the camera in the hand. Alright, that one is done. I just go to SDM2, zero that, and I'm going to do the other two holes off camera, here at the back, and then share the next steps. This DRO is a must-have. Got one of these machines, it's going to save you a lot of time, and the labor that you save is going to make up for the cost of that DRO. Okay, I've placed my machinist jack underneath this parallel clamp of mine. Prevented because it was moving. Now this whole machine in the back is rounded, and in the front where this bracket mounts to the machine is not very rigid. Okay, that's center drilling done. So what I'm going to do now is take it out and finish the holes up in the drill press, because I'm not going to be able to fit in a full-size drill in between the machine and this cover. So I hope I taught you something. Okay, all the holes are lining up and the cover is sitting very nicely. Now I don't have the correct size screws for this, so my brother will need to source them. Now I did countersink them for countersink bolts. I'll just give it a nicer look. And this is not a surface on the machine that's going to be used for location. That's what this foot is here for, because your blade sits on this side, so there's no way that you use this for any reference. So yeah, that in a nutshell, this job is done. I think it will serve the purpose, and I think it looks good. Now, I don't know if the camera is doing it any justice, but the surface finish on this plate with this metal is almost like cast iron. It behaves a lot like cast iron, except for the fact that it's stringy. So it's basically a combination of a whole lot of different materials, different properties, all combined. So if you enjoyed this build, it is in the beginning it was looking very tricky, and I was wondering how I'm going to tackle this thing, because cutting it out of a hacksaw or with a grinder and filing it into spec was going to take quite a long while, and it wouldn't have nearly looked as nice as this plate does. So until next time, cheers.